All right, so in today's video, if you are an online student taking this class online, you can go to the course webpage and download this file. It's called Ionic Compounds Practice Problems, and then you can do the problems fully on your own. And then when you're ready to see the answers, you can check out the video. There's a PDF posted on the course website, and that's the same for you too on-campus students as well. I'll post a PDF of the answer key, so if you want to, as you're studying for the test, you want to go back and look at it, it'll be there for you as well. Although you'll have all the answers here in just a minute, but you know, dog eats your homework, whatever. You have the option. If you're just watching this online as online student without the PDF, you can pause the recording, try the problem on your own, and then hit resume when you're ready. So these are the problems that we did on campus today. Try them for yourself. We've got some naming, and then we've got some formula writing, and then you are grading some quizzes, and you're grading your student's work and deciding if your student is correct or incorrect. Same thing, you're grading some student work, and you're determining if these formulas are correct or incorrect. So what we're doing in this video is just going over these problems. I'm going to go over them all right now, and then you'll have all the answers. So let's zoom in just a little bit too much. How do monatomic ions differ from polyatomic ions? Let's look at the prefix, mon versus poly, right? What's a monatomic ion? It's just one single atom, right? One single atom. That's one difference. Poly means many, right? So what's a polyatomic composed of? It's a group of atoms, right? And there are some other differences. That's just one of the differences. This is a single atom, and it has a charge, I should say, based on number of valence electrons, right? And we get that from the periodic table. If you go back and look at your notes from how do we get the charge of an ion, right? We're looking at the periodic table. So if this is our handy dandy periodic table, all the ones in group 1 have 1 valence electron. Right? All the ones in group 2 have 2 valence electrons. We skip the transition metals. All the ones in group 3 have 3 valence electrons, 4, 5, 6, 7, and 8, right? And if you are an atom, you wake up in the morning, your goal is to have either 0 or 8 valence electrons, right? And so you want to get to either down to 0 or up to 8. So you ask yourself, okay, if I'm in group 1, which is easier, gain 7 or lose 1? We're going to lose 1, right? That's why everybody in group 1 as a monatomic ion has a +1 charge. Because if you lose something that is negative, that makes you positive, right? Everybody in group 2, if you lose 2 electrons, because it's easier to lose 2 than gain 6, right? These all have +2 monatomic ion charges. We skip the D block. It's easier to lose 3 than gain 5, right? That's why everybody in group 3 has a +3 monatomic ion. Group 4 actually doesn't do either. It doesn't form ions, so we don't worry about them. When we get to group 5, is it easier to lose 5 or gain 3? Now it's actually easier to gain, right? And electrons are negative, so we're gaining something that's negative. So if we gain 3, that gives us a -3. Lose 6 or gain 2, well, it's easier to gain 2. Lose 7 or gain 1, it's easier to gain 1. And then group 8, they don't have to worry about that, they already have 8 valence electrons. Right? So the monatomic ion comes from the charge, the charge of the monatomic ion comes from number of valence electrons from its position on the periodic table, right? So if I said, what's the charge of sulfide? You look up, sulfur's in group 6, so when sulfur becomes sulfide, it has a -2 charge, right? Whereas a polyatomic ion, how do we figure out their charge? Do we go to the periodic table? No. Charges must be what? Right, you got to memorize. So for example, this would be sulfide, IE suffix, whereas this will be sulfate. And I mentioned this in the notes in the lecture. If you want to write it as S2 minus or as S minus 2, I really don't care which you put first. Whether you put the number first or the charge first makes no difference to me. Some students prefer to put the charge first and then the number. Some students prefer to put the number first and then the charge. And then textbooks get kind of inconsistent about that too. So I don't care which way you put it. Okay. Same with the polyatomic. If you want to write polyatomic ions as SO4 2 minus, or if you want to write it as SO4 minus 2, I'm not going to get obsessive about that. Okay, because as long as you've got the formula and the charge together correctly, that's all I'm interested in. Okay. We good on number 1, differentiating between monatomic and polyatomic. All right. Which formula is correct? The one on the left or the one on the right? CaOH2, no parentheses, or Ca parentheses OH2, which one? The one with the parentheses, right. I see this mistake so often. I mean, I just can't even explain how many times I see this mistake, which is why I put this on these problems. Why is this correct? Right. This formula is saying I've got 1 calcium atom, 1 oxygen atom, and 2 hydrogen atoms. Right? That's what that formula is saying. Whereas this formula is saying I've got 1 calcium and 2 OHs, right? This is made, calcium hydroxide is made from 2 OH polyatomic ions and 1 calcium, right? So it's 2 plus and 1 OH minus. Okay, that's what was used to make this. If you go back and look at how you made that, CaOH2, right? When we uncrisscross these, we get Ca2 plus and OH minus, right? We crisscross them. Good. Questions on 2? All right, let's do the next section. Naming formulas is so important. It's such a crucial skill. It's something that's going to be with us for the remainder of the semester and the remainder of your chemistry career, really. So let's go through and name these. What's the name of AlCl3? Aluminum chloride. Good. Aluminum chloride. Any questions on A? What's the name of B? Lithium nitride. Good. Lithium nitride. What's the name of MgO? Spell check doesn't like that, so just ignore that. Right? What's the name of MgO? Magnesium oxide. Good. D? Good. Why is it copper 2 and not just copper sulfide? Okay, right. Anytime you're dealing with an element that's in the D block, right? D block elements plus tin and lead. Because tin and lead are technically not in the D block, they're in the P block, right? But they can form cations of multiple charges as well. Anytime you've got a cation that's in the D block, like copper, right? You have to figure out what its charge is because there's no hard and fast rule for figuring out the charge of the D block element, right? So you've got to work backwards. So if we've got CuS, we say to ourselves, okay, sulfide is -2, and for this to be a 1-to-1 ratio, that must be copper +2. Yes. So if you forgot the 2, that would just be a -1/2. If everything else was correct and you just forgot the copper 2, I'd usually just take off 1 for that. If everything else was correct. Okay, E. What's the name of E? Good. Lead to bromide. And again, Lead is technically not in the D block in terms of where it's located, but it can form multiple charges, which is why it needs the 2. CuCl, what's that? Good, copper 1 chloride. Okay, what about BaI2? Barium iodide, good. And then H, calcium oxide, good. And I, copper 2 chloride, good. Now, in all of these, in number 3, are these monatomic ions or polyatomic ions? These are all monatomic, right? These are all composed of monatomic ions. And you can tell that a couple different ways, right? It's just one element and one element, right? Or another way you can look at it, there are no parentheses, right? Also, they all end in "ide," right? So there are a couple ways that you can distinguish that. These all came straight from the periodic table. You didn't have to memorize the formula for any of those. Any questions on 3? So far, so good? All right. Let's go on the other direction. Taking a name and writing formulas. So this is where we're going to want to start doing the crisscross method, right? So barium is in what group of the periodic table? Group 2, so that means it's got a charge of +2 as a cation, right? And oxide is in group 6, right? So do I need to write this formula as Ba2O2? No, I use the lowest ratio would be what? BaO, right? Just BaO. Okay, potassium carbonate. Where's potassium on the periodic table? Group 1, right? It's right there, so it's K+. And where's carbonate on the periodic table? It's not, right? Carbonate's polyatomic ion with what formula? Right, CO3 -2 or CO3 2-, right? So when we crisscross those, this 2 goes here, this 1 goes here. Do you need to write a subscript of 1? No, it's unnecessary. So the formula is K2CO3. Do we agree? Now remember, when you're writing formulas, I see this a lot, especially with polyatomic ions. Does your final answer include any charges? No, never, ever, ever, right? Because when the positives and the negatives cancel each other out, there's no net charge. It's always neutral. All right, calcium's where on the periodic table? Group 2, right? So that's Ca2+, and chloride is where on the periodic table? Group 7, so that's Cl-. So when I crisscross those, that becomes CaCl2. Okay, this 3, what does that tell me? Does it tell me that it's this, or does it tell me that it's that? This one, right? A lot of students do this. They say, so, oh, okay, that 3 tells me that there are 3 cobalts. That's not correct, right? What is that Roman numeral telling me? It's telling me the charge on cobalt is +3, right? It's a +3 cation because cobalt is right here in the D block, and those D block elements, we need to specify what their charges are. What's nitride? Where's nitrogen on the periodic table? Group 5, so it's got a -3 charge. So is it CO3N3? No, it's what? It's just C-O-N. Be careful here with your case, right? If this looks like an uppercase O, that would be incorrect, right? Because that would be carbon, oxygen, nitrogen. That's not correct. Be careful with O's especially. Okay, E, manganese 2. What is that 2 telling me? It's got a +2, right? Mn2 plus or Mn +2, either one, because manganese is right here. It's in the D block. No hard and fast rules for transition metals, so we've got to work backwards. Where's phosphate on the periodic table? It's not. What is phosphate? All right, PO4 3 minus. So when I do this one, am I going to need parentheses? Yes. Mn3 PO4 2. Questions on E. And F. Magnesium's where on the periodic table? Group 2, so that's Mg2 plus. And sulfide is what? Group 6, S2 minus. So when I crisscross those, it's Mg2, S2. We don't need that. It's just what? Mg, S. Good. Questions on number 4. Feeling good? 100% so far? All right. Let's go on. You are grading your students' quiz. In the quiz, you ask your students to name an ionic compound. The formula the students were given, so this is what I gave them on the test, is here, and this is what the student answered. And then you need to be the teacher and decide, is it right or is it wrong? Okay, so if the student wrote this, or if the student was given this and the student wrote this, is the student correct in number 5? No, the student's wrong. No, not correct. So you being the good teacher that you are, you always correct your students' work. What's wrong with the student's work? You need the Roman numeral, right? What is the Roman numeral? Lead 2. Good. So if you did this as a student and I'm coming along grading it, everything else is correct, I would probably take off half a point for that Roman numeral. Okay, 6. Aluminum nitrogen oxide. Correct or incorrect? Incorrect. This tells me, when I see this, that you haven't what? Memorized your polyatomic ions. Because when I see this business, that tells me you don't know what that is. And so you're trying to just do your best to fudge it, right? This tells me you haven't memorized your polyatomic ions. So that is incorrect. What's the correct name? Aluminum nitrate. Good. Alrighty. Potassium carbonate. Is the student correct in number 7? Yep, nothing wrong with that. Nothing wrong with that. Any questions on how you graded the student's work? Okay. All right, same thing. You're grading your students' work. In the quiz, you ask the students to write formulas for a compound. So this is what I asked you to do. This is what the student did. We're going to grade our student and find out, is our student correct or is our student going to lose some points? Silver 1 chloride. Student writes AuCl. Correct or incorrect? Correct, correct. Here's some votes for correct. This one's incorrect. Silver has what symbol? Ag. Silver is Ag. What's Au? Oh, that's gold, right? It should be AgCl. So Mistake between silver and gold. All right, number 9, aluminum acetate, Al2C2H3O23. That's incorrect, right? This is a common mistake I see as well. What problem did the student make? You don't need this 2, right? So in other words, the student thought that acetate had a -2 charge, right? Acetate doesn't have a -2 charge. What does it have? A -1, right? So it should be Al what? C2H3O23. Everything's okay except that 2. This is a mistake I see a lot. For whatever reason, students memorize acetate as a -2 charge, and it's not. It's a -1. Okay, number 10. Is that correct or incorrect? That's incorrect. What did the student do incorrectly? All right, they wrote iron 3 nitride instead of iron 3 nitrate. So what should the formula be? All right, because nitrate is NO3 minus, and this is telling me it's Fe plus 3. So when you crisscross those, that's where the formula comes from. Nitride and nitrate get mixed up by students a lot too. Try to make up ones that I see a lot so that hopefully you don't make those same mistakes. Any questions on these ones? Grading your students' work. Because if you can grade someone else's work and evaluate where they are, that usually means that you've mastered the material too, which is a good thing. Okay, for these problems, I've given you a formula, and then you decide, is this formula correct? If it's not correct, what should it be? And then also give me the name. So, is LiS2 a correct formula? No, it's not. What should it be? Li2S, right? What did the student do? They just goofed up when they crisscrossed, right? Because it's Li plus and S2 minus. Right, so when they crisscross that, they put the 2 in the wrong place. It's a really common mistake I see. Li2S is the correct formula, and what's the name of that? Lithium sulfide, good. NH42NO3, is that a correct formula or not? Nope, that's wrong. What mistake did this student make? This 2 is unnecessary. Why? Right. Ammonium is +1, nitrate is -1. Right? So the student thought that nitrate had a -2 charge when it didn't. Right? Because this is, oops, NH4 plus and NO3 minus were the cation and the anion. So it's just NH4, NO3. What's the name of that? Ammonium nitrate, good. All right, number 13. Is that correct or incorrect? That one's fine, yep. Because barium is +2 and phosphate is -3. Everything's good there. So what's the name of this? Barium phosphate, right? Kind of revealed the answer there to you. Okay, MgCl, is that correct or incorrect? Nothing correct there, right? Well, I mean, you're almost there, but not correct. What's wrong? Right, magnesium's +2, and chloride is what? -1. So when you crisscross those, it should be what? MgCl2, which gives us the name magnesium chloride. Good. NaO. Is that correct? Nope. What should it be? Na2O. Good. Why should it be Na2O? Because Na is +1, O is 2 minus. Right? When you crisscross that, it gives you the Na2O. What's the name? Sodium oxide. Okay. 16 we've actually already done, but it's just so important I put it on there twice. Is that correct? No. And I see this mistake so often with hydroxides. Whether it's calcium hydroxide, barium hydroxide, magnesium hydroxide, aluminum hydroxide, I don't care what hydroxide it is. For whatever reason, students love to make this mistake. And what is the mistake? You forgot the parentheses. Right. It should be CaOH2. And like I said, I don't really care which hydroxide it is. Now, if it's, let's say, sodium hydroxide, would you need parentheses for NaOH? No. So this is calcium hydroxide. Please put a star next to this, right? That is such a common mistake. Very common error. Okay, I see that so often. And last one, AlSO4, is that correct? No. What's wrong there? Right, we didn't crisscross correctly. What is aluminum? Al with what charge? +3. And SO4 is -2. Right? So when I crisscross those, it should be Al2 SO4 3. What's the name? Aluminum sulfate. Good. How do we feel about this? Feeling pretty good? Okay. So there are lots of other problems to try just for practice, posted on the course website with the answer keys as well. If you want even more than that, I've recommended ones in your textbook. You can look at the syllabus. And I think just the act of doing the homework on this will be pretty beneficial as well. So that's where we're going to stop.